Okay, so this video is going to be about analyzing this scan. Now, I still have my initial surface that I created, and what I want to do is talk about the quality of the scan itself. So this is a scan of an existing part. It's a plastic injection molded part, and it's been painted, and there's coating on it of some sort, and the part itself was, I do believe, in use for a little while, so there's going to be some surface abnormalities and defects and so on and so forth. Now, with that said, a scan is going to pick up everything, even if it's just a surface abnormality, like a witness line of some sort. Like if this were a machine surface and I run a fly cutter, you see the little swirls on that surface. A scan is using light, and how that light reflects back to the scanner is what is picked up. And because of that, surface abnormalities, even though they're not technically part of the part, that are there, maybe the part's perfectly smooth, but it just has a abnormality. So those kinds of things are things that we do not want to reverse engineer on our part. So the question becomes, well, for me, I get a lot. Well, how do you know you're designing it right? Or what's the tolerance to the scan? Or what's this? Or what's that? There's a million questions. Those are the kind of questions that I had when I first got in. And over the years, the near 25 years I have doing this, with surfacing and stuff like that, what I have found is that, again, the scan or the sections, whatever it is you have, point cloud, is merely a suggestion, okay? Because there are going to be parts of whatever it is you have that are not good, that you do not want to show in your final product. So using this scan as an example. Now, let me go ahead and hide that surface. Let me hide these edges. So as I inspect this, there's stuff that I can do with, okay, first thing I'm going to do is I'm going to go into a studio, and it's going to go into a perspective, and it's going to change the lighting and stuff like that, and the shadows and all sorts of stuff. So I always do something like this with my data to give it a good once over to see if I can catch anything just with my naked eye. Okay. And as I look at this, I see some little abnormalities here, there. I'm going to go back to a regular view, maybe pop out a little bit more. I'm going to see how the light reflects on that surface. You can see right through this corner the shadows as they walk around, and I see the way the light's tracking up and down. Now I want to exaggerate that. This is a very important thing to remember. This is an injection molded part, and all injection molded parts, anything that's made basically, is going to have some deformities in the final part, depending upon I don't have the rib structure on it, how it's fastened, if there's bosses, pockets, pads, anything like that that could potentially cause something to distort the surface. So I'm going to go ahead and do a curvature. I'm going to pick this. Actually, no, I don't want curvature. I want reflection. I'm going to pick this guy, and I'm going to walk this line across that surface. Okay, this little line that you see here. And let me make it a little bit finer. So what I'm looking for are any abnormalities. Now these, it's kind of jagged because it's a scan. I expect that. But there's also a general shape to the part. You can see that there's a general shape that flows in and out and comes down, etc., etc. Same thing on this face, same thing on this face. Okay, you can get an idea of what the surfaces need to look like. You can see as you come down here, we get that shape. It likes to swing, kind of what I put into my surface. Likes to swing down and out, which is basically what I have on mine. So I'm keeping the characteristics of it. Now when I get into this view, you'll note here that light comes up and it looks like it almost kind of bubbles and waves a little bit. My guess is that is part of the manufacturing process. Okay. Now, cancel that. Another tool that I like to use is called sectional analysis. Okay. What do I want to section? You can see the face or facet. I want this. What plane do I want to section against? And for my plane, I want to section against, we'll say, this guy. And this is just temporary. I want a number, and I just want 1. Otherwise, the screen gets pretty busy. Now, what I can do with this is I can drag this and get an idea of, let me actually increase the scale factor. And the number of needles to smooth this out a little bit. There we go. I can get an idea of what's going on with that surface. And you'll see that there's a crown as I walk that section down. So there's that gentle crown on that surface, so we know that it's got that positive curvature. And that's just in this one direction. And as you'll note here, as you get into this corner, that crown looks like it's kind of tilted a little bit. Again, because now we're getting into the main body. And this, I would guess, is some sort of deformation on the part. Because when I go a little further forward, okay, you'll see, I know it's kind of hard to make out, but I'm so used to looking at stuff like this that there's a more of a constant general crown shape. And as I get further back, it begins to, as you can see, again, flatten out as it gets towards the bottom, as we get back here. Now, I'm going to orient this one more time to this view. And let me cut that section. Now, as I cut that section, actually, let me just go with this view. It was a combination of the two planes is why I was getting that. Now, I want to go to this section. And once again, I'm going to increase my needle scale. And let's see. What I want you guys to look at is, see how the needles here dive in and go behind the part? And that's a big tell. So what this is saying to me, as we get back here into this blend, is that this surface is, and again, I'm going to go with, this was deformed when it was pulled out of the tool. I'm going to say that this surface looks like it's coming in, and to exact, let me come this view with it. And it's an exaggeration of what's going on, but the curvature reverses. So what's happening is the surface has a crown in this direction, and then it wants to swing back up in this direction to come into the blend, which is normal. So what this tells me is I do not want to design this little inflection on that surface coming into that blend. Okay, chances are, judging by when I get closer to the top, you'll note as I get up here, obviously they get smaller and smaller and smaller. I have a blend in that surface, and right about here is where that blend begins and ends. And I come straight down, and that, you can sort of see that light running along that surface. That's where the reversal is going to happen, or the change in direction is going to happen, is right along that tangency. I don't want it to happen way back here, right? That's not what I want. So I'm going to make a judgment call that I need to deviate a little bit more over in this area in order to make that side surface, make it smooth. Because once I make that surface, I'm going to get all these surfaces in there. I'm going to put in a blend. Well, that blend is going to be where that curvature changes, right, at that tangency. Okay, and I could do the same thing for the forward end. Just taking a look over here and sort of get an idea of what's going on. Okay, nothing too crazy, pretty much what I expected. And again, I would offer that. Let me reduce the scale of the needles a little bit. I would offer, let me put this over here, I'm just dragging it by the ball, putting it near an area that I want to inspect. We have our crown, this is the blend, and then again, once again, you'll note that this comes in, and it looks like there's a slight little pucker in here, and then it flattens out again. And I'm kind of picking that up, and what this happens is, again, it happens a lot of times into blends. Going into those corners, there's a little distortion on that surface. That's totally normal. Again, do we want to design that distortion into our final product? And I'm going to go out on the shortest limb and say no. So if we were to do an overlay of the original data to what came off of the press, there was probably a profile tolerance of, I don't know, a mil that they were allowed to be off, maybe even more. And then remember, this thing was bolted onto the front of a scooter and driven around, hot, cold, wet. All sorts of weather conditions are going to cause this to shrink, twist, distort, etc., etc. So as we're designing our parts from these types of scans, we have to knowingly understand, right? We have to put it in our heads that the scan is basically a Cliff Notes. Right? It's just giving us the overall sort of shape that we want to attain. And putting that in our head, obviously in some cases, if you get a clay scan that's been milled out and smoothed out and so on and so forth, you're probably going to want to get pretty maybe closer to something like that. There's going to be times where I was working off of a clay scan and the stylist asked me to pull something 25, 26, 27, I think it was like almost 30 millimeters away from scan on an area just under the handle because it needed additional width, thickness, material, fasteners, and so on and so forth. So again, what you are doing is using that scan as a basis for your surfaces. I do not want to make a surface that fits perfectly on any of this stuff, because if I do, let's do this. I'm going to go in here, I'm going to say 4-point surface, and I'll just do something on this side right over here. Select OK, and I'm going to go into reverse engineering. I'm going to fit my surface. Actually, no, I don't want to fit that. I want to, hold on one second. Actually, you know what? I'll use fit. I'll just do that instead. I was going to project it on, but I'll just do this. This will be actually easier to show. So I'm just going to capture that area and say, all right, I want to fit a surface on this area. This is where I determine that that surface kind of dives in and does things that I don't necessarily want it to do. And then, let's see here, I'll turn on single surface. Okay, maximum error is pretty tiny. Let me preview that. Let me look at that. Yep, looks pretty good. Looks really, really good. Select OK. Let me get rid of that. Now, let me look at the surface. And when I say look, I mean inspect it. And like I said, there was that area on that where the contour switches over, and it's right where I said it was. So by putting that surface on there, it's still a relatively clean, simple surface. This is telling me that, okay, that there's a switch on that surface. You can see it plain as day. Let me show the facet body again. Right? And right where I said it was going to be. You can see it's a big, gentle blend. So my guess is that as this blend comes around to this corner, it's causing some distortion on the primary, which is normal, and we have to be aware of that kind of stuff. Okay? And if I try to fit this too tightly, let me do some reflections on this guy. And actually, let me go line images. Go here. It's a small surface, and it's not going to look terrible, but you can get an indication, an idea. Let me go with ultra fine. Let me turn up the line count and see if I can kind of judge it. I can see that it wants to, you can see how here they're kind of concentric, and over up at the top how they kind of flatten and straight out a little bit. Do we want to see that in as part of the surface? And again, this is just a little section. If I were to do that whole side, I'd end up with a far more exaggerated version of what you're seeing here. You can see how these contours flow nice, and this, once you get up to about this green one, you'll notice they start flattening out as they go forward. So this is telling me that there's a little distortion in that surface. So just by doing that quick little analysis and having a look at it, I can make a good judgment call saying whether or not I want to deviate from an area or hold it closer or tighter to a certain area to get the final result. And when I say deviate, I might deviate 1 mil, 2 mils, 3 mils based on this part and the final result that I want. Okay, again, this is just a rough scan of a part that was on something, that was out in weather, that was injection molded and then attached, fastened. Right? We had fasteners here. There's some in the middle, up the side, in the back. So we know those are going to distort the part, etc., etc. So, is it going to distort 1 mil, 2 mils, 3 mils? Yes, it's plastic. It's plastic. The caps on a truck bed in cold weather versus hot weather, like in Michigan, you have a 8-foot-long truck bed, and you have those little caps sitting on top. On some of those, you'll have clearance for 25 millimeters of expansion and contraction, swinging between hottest weather and coldest weather. So it can be pretty extreme, depending on many, many factors. So expect to deviate from the scan.